recording book. Yes, yes.
Good afternoon, sir. I am Ankita Dikshit presenting my seminar for the Pre Ph.D coursework on the topic of biodegradation of plastic using microorganisms under the guidance of Dr. Rajendra Joshi, R.D. Joshi, sir. Uh,
Yes, you can continue.
yes, sir. First of all, we will see the definition of plastic. Um, Plastic is defined as a material consisting of large molecular weight organic substance. It is also categorized as a polymer composed of long carbon chain. It consists carbon, hydrogen, silicon, oxygen, chloride, and nitrogen. It is derived from different sources such as oil, coal, and natural gas. Plastic are extensively used because of their stability and durability. Just a minute, sir. So my slide is showing there.
Yes, yes, only introduction. First slide is there.
Yeah, okay.
Second slide is not. Yes, you can change the slide.
Yes, sir, sure. Then history of plastic. Plastic was accidentally discovered in 1846 by German scientist. When he is experimenting in his kitchen, he spilled a mixture of nitric acid and sulfuric acid. He used a cloth to clean up the spill, and later he placed the cloth on the stove. To his surprise, the cloth was vanished and leading to the discovery of plastic. Then we will see what are the type of plastic. Based on their physical property, plastic are categorized into two types, that is thermoplastic and thermosetting plastic. Thermoplastic, this plastic can be easily reshaped when they are heating. They are flexible. They include linear polymer and combination of linear and cross-link polymer. Example of these plastic are PVC, nylon, and polyethylene. Thermosetting plastic, uh, these plastic, when they are molded, this plastic cannot be softened after reheating. They consist of heavily cross-linked polymer. Example of this polymer include bakelite, which is used for making electrical switches, and melamine, which is used for the floor tiles. Then uses of different type of plastic. The plastic are created by linking various monopolymer subunit to form polymer. Will While all plastic are polymer, but not polymer are plastic. There are several type of plastic commonly used in worldwide. First is LDP plastic, which is called low density polyethylene. It is used in the production of frozen food bags, squeezable bottle, and flexible container lid. Then high density polyethylene, which is also called HDPE plastic. It is used for the milk, juice, and water bottles. Uh, as well as trash and retail bags. Polyvinyl chloride, also called as PVC. It is employed in the making juice bottles, raincoat, visors, shoe soles, garden hose, and electrical pipes. Polystyrene. It is used in the laboratory ware, packaging material, disposable cup, plates, and tray. Polypropylene, commonly used for the bottle caps, drinking straw, medicine bottles, and car batteries. Here we are. I am going to show the global production of plastic. The creation of the first synthetic plastic is bakelite, which is synthesized in the 1907, marked the inception of global plastic industry. However, it wasn't until the 1950s that global plastic production saw rapid growth. Over the subsequent 70 years, annual plastic production nearly 234, reaching 460 million tons by 2019. In the graph, here we can show after the uh, 2000, there is tremendous production of increase in the increase in the plastic production. Uh, there are several traditional method for the disposable of plastic. As we see in earlier slide, here is the tremendous amount of plastic is produced worldwide. So we need to decompose that plastic. So here are some methods which are traditionally used for the disposal of plastic. First is landfilling. It is used worldwide almost 75 to 5%, in which 26.97 million of ton plastic is decomposed. Landfill takes up the incredible amount of space, and potential use of plastic is lost when they are disposed by the landfill. Additionally, in areas with poorly managed dump, plastic waste like bags and bottles can be blown out into the ocean and waterways. If plastic are allowed to stay in dump, they will be eventually start to decompose and leak the pollutants. Second method is the insertion, which is globally used almost 15.8%, in which 5.62 million ton plastic is decomposed. Insertion is the method uh, in which plastic does not that ability to produce energy that can be harnessed for power. 1 pound of plastic creates some amount of energy as a similar amount of coal when burned. Unfortunately, insertion plastic also leads to more extreme pollution. Most plastic can be made with PVC and halogenated additives that become dioxin and polychlorinated biphenyls uh, when they are in the environment. Third method is the recycling, which is used very less, which is 8.7 for the disposable of plastic, in which 3.09 million ton of plastic is decomposed. Recycling is working when the with the traditional plastic. Recycling is one of the many options as allows the plastic to get more use for their lifespan. Recycling is often purely utilized due to the pure collection and sorting processes. So what are the environmental impact of plastic? As we see, there is a huge amount of plastic is produced globally, and we use it in our daily life. So it causes hazardous effect on the environment. So here we will see what are the impact of plastic. So first, soil environment, aesthetic and hygiene. It is impact on soil environment, like it reduces the soil fertility by forming a part of manure for years. In landfills, it emits hazardous volatile organic compound during the insertion. Is lesser the growth of plant and trees by blocking the absorption of mineral, water, and other nutrient from the soil. Overall, a million seabirds and animals die annually from the injection of the plastic. So this plastic produces the huge amount of pollution in the environment. Plastic pollution nowadays, plastic pollution is a global issue with millions of tons of waste harming land, waterways, and ocean. Wildlife suffers from ingestion and environment, and microplastic contaminated soil and water entering the food chain. This poses health risk to human and animal. Solution include reducing plastic use, improving waste management, and promoting recycling and biodegradable alternatives. As we are the microbiologist, so we will go for the biodegradation of plastic using microorganism. So what is the biodegradation? It is the process by which organic substances are broken down by living organism in term of the term is often used in relation to ecology, waste management, environmental remediation, that is bioremediation, and plastic material due to their long lifespan. Organic material can be degraded aerobically with oxygen and anaerobically without oxygen. The term biodegradation to biomineralization, in which organic matter is converted into minerals. Plastic are biodegraded aerobically in wild nature, anaerobically in a sediment and landfills, and partially aerobically and partially anaerobically in compost and soil. Carbon dioxide and water are produced during the aerobic biodegradation, and carbon dioxide, water, and methane are produced during the aerobic biodegradation. Generally, the breakdown of long polymer to carbon dioxide requires several different organisms, with one breaking down the polymer into its constituent monomer, one able to use the monomer and excreting similar waste compound as byproduct, and one able to use the extracted waste. Biodegradation is governed by three factors, which include polymer characterization, type of organism, and nature of the pre-treatment. Generally, an increase in molecular weight result in the decline of polymer degradability by microorganism. In contrast, monomer, dimer, and oligomer of the polymers repeating unit are much easily degraded and mineralized. Higher molecule weights result in a sharp decrease in solubility, making plastic unfavorable for microbial attack because bacteria require a substance to assimilate through a cellular membrane and then further degraded by the cellular enzyme. At least two categories of enzyme actively involved in the biological degradation of polymer, that is extracellular depolymerase and intracellular depolymerase. Biodegradable materials degrade into biomass, carbon dioxide, and methane. In case of synthetic polymer, microbial utilization of carbon backbone as a carbon source is required. Natural polymer like protein, polysaccharide, nucleic acids are degraded in biological system by oxidation and hydrolysis. So here are some microorganisms which are help in the degradation of plastic. In bacteria, Bacillus pseudomonas, Calcibia, Nacordia, Streptomyces, Thermoactinomyces, Micromonospora, Mycobacterium species, Rhodococcus, Flavobacteria, Escherichia, and Azotobacter. Some of them are accumulated polymer up to 90% of their dry mass. Fungi which are used in the degradation of plastic are Candida, Penicillium, Sprototrichum, Geotrichum, Caldosporium, Taloromyces, and etc. So there are two type of biodegradation, as I discussed earlier, that is aerobic biodegradation and anaerobic biodegradation. In aerobic biodegradation, it is also known as the aerobic respiration, and it is an important component of the natural attenuation of contaminants at many hazardous waste sites. Aerobic bacteria use oxygen as an electron acceptor and break down the organic chemical into smaller organic compound. Often they are producing carbon dioxide and water as a final product. Here we see in aerobic biodegradation, polymer in presence of oxygen converted into the carbon dioxide, water molecule, and biomass. While the anaerobic biodegradation or anaerobic respiration is an important component of the natural attenuation of contaminants at many hazardous waste sites. It is breakdown of organic contaminants by microorganism when oxygen is not present. So aerobic bacteria use nitrate, sulfate, iron, manganese, and carbon dioxide as their electron acceptor and break down organic chemical into smaller compound. Here we can see polymer in absence of oxygen convert into carbon dioxide, methane, hydrogen molecule, and biomass. This is the steps of plastic degradation by microorganism. First is biodeterioration, in which the combined action of microbial community and biotic factors to fragment the material into tiny fraction. Then biofragmentation. Biofragmentation is the lytic process in which bond within polymer are cleaved and generating oligomer and monomer by ectoenzyme or free radical secreted by microorganism. Third is the assemblination, in which molecules are recognized by the receptor of microbial cell and can go across the plasma membrane. And third is the mineralization. Mineralization is the simple molecule, making molecule polymer simple in the carbon dioxide, water, nitrogen, and methane, and different salt and intracellular metabolites, they are completely oxidized and released in the process of mineralization. Here are the general mechanism of enzymatic cleavage of the plastic material using microorganism. In the mechanism, at least two category of enzyme are actively involved in biological degradation of polymer. Uh, that are extracellular depolymerase and intracellular depolymerase. The main group of microorganism and the degradative pathway involved in polymer degradation often depend on the environmental condition. Enzymes secreted by the microorganism for biodegradation of plastic are mostly lipase, protease, dehydrogenase. During degradation, exoenzymes from microorganism break down the complex polymer, yielding smaller molecule of short chain, that is oligomer, dimer, monomer, that are smaller enough to pass through semi-permeable membrane, outer membrane of bacteria, and then to be utilized as a carbon as an energy source. This process is called as depolymerization. When the end products of this process are carbon dioxide, hydrogen, this degradation is also called as a mineralization. So which enzyme are involved in the degradation of plastic, and which by which organism? So first is the lackages. It is produced by actinomycetes, rhodococcus rubber. It involved in the biodegradation of polyethylene. So the enzymatic degradation of plastic by hydrolysis is the two-step, um, in which firstly enzyme is bind to the polymer substrate, then subsequently catalyze hydrolytic cleavage. Polymer degraded into low molecular weight oligomer, dimer, monomer, and finally mineralize to carbon dioxide and oxygen. So lackases are mostly present in the lignin degrading fungi and actinomycetes. When they catalyze the oxidation of aromatic compound occurs. Lackases activity is known to act on only non-aromatic substrates. So second is the papain and urease enzyme, proteolytic enzyme found to degrade the medical polyester polyurethane. So polymer degraded by the papain was due to the hydrolysis of urethane and urea linkages producing free amine and hydroxyl group. Some strains which are capable of degrading the polyethylene are Bacillus species, where proteases are responsible for the degradation. The enzyme responsible for biodegradation by Pseudomonas species are serine hydrolysases, esterases, and lipases. By these methods, the microorganism can degrade the plastic. So here are some standard biodegradability testing methods. In which first is the visual observation. In this method involves the visual observation changes in the appearance of plastic sample over time, such as cracking, discolor, or fragmentation, or indicating these characteristics indicating the degradation. Then the weight loss measurement. In this method, the weight of plastic sample is measured periodically to track any reduction in weight due to the degradation process. So in this process, the initial weight, that is before treatment, and after treatment weight after treatment by the bacteria or microorganism is taken, and then the comparison of that two like control and test sample of plastic was taken there, that show the degradation of plastic by weight. Then CO2, carbon dioxide evaluation, and oxygen consumption. This method measure the amount of carbon dioxide produced or oxygen consumed during the degradation of plastic sample, providing insight into the rate of biodegradation. Uh, la then radio labeling. Radio labeling involves the incorporation radioactive isotope into the plastic sample, which allow to track the breakdown of plastic molecule over time using specific detection equipment. Then clear zone formation. This method assesses biodegradation by observing the formation of clear zone around the plastic sample in a nutrient-rich medium, indicating microbial activity and degradation of the surrounding materials. After that, some high throughput techniques were also used for the detection of plastic degradation, in which FTIR is used, and scanning electron microscope is also used. Then what we can conclude from this today's seminar: microbial degradation of plastic is promising eco-friendly strategy which represent a great opportunity to manage the waste plastic material with no adverse impact. So the safe disposal of plastic waste by biodegradation should be focused on the most consumed polymer like polyethylene, polypropylene, polyurethane, and polystyrene. Unfortunately, these polymers are also long lasting as well as most durable plastic. In view of this problem, several tasks should be addressed in order to get safest disposal. So one of the most successful method to handle this problem is enzymatic biodegradation of plastic that will be enhance the degradation of rate. Thank you.
Thank you, Ankita Dikshit. Now, this was a well-designed presentation which was made by my research student, Ankita Dikshit. Now, it was expected that the student should not only focus on the research topic or the PhD topic. The student should have an aptitude of research regarding the environment or regarding the exact research type which is going on in the subject. So, incidentally, Ankita Dikshit had chosen a different topic than her research topic, but we are facing a huge problem of plastic pollution. Nowadays, bioplastics are being introduced into the society, which are also useful. But still, in our home or in our society, we see a huge amount of plastic which is not biodegradable or not easily biodegradable. So definitely this was a good presentation, and any student in future, if he or she wanted to pursue his or her research in plastic biodegradation, that student will get definitely some direction from this presentation. So thank you very much, Ankita Dikshit, for your presentation. Thank you.
Thank you so much, sir. Thank you.
Thank you. Thank you.
Thank you.